Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in this video we will study the classification of measuring instruments. So let us start with our topic. The measuring instruments, they are defined as the instruments or the device which is used for the measurement. For example, the rulers. The rulers are used for measuring the length. So ruler is a type of measuring instrument. Another example is like thermometer. We use the thermometer to measure the temperature. So thermometer, it is a type of measuring instrument. Another examples are like weighing machines, stopwatches. In the case of engineering, if we take, the measuring instruments are like the ammeter, which is used for measuring the current, the voltmeter, which is used for measuring the voltage. So measuring instruments, they are the devices which are used for the measurement of the unknown quantity like temperature, pressure, level, displacement, voltage, current. Okay. So definition of measuring instrument is device which is used for measuring the unknown quantity. Now the various type of measuring instruments, they are classified into different categories, and these categories or the basis of this classification will be like whether they are using what type of method of measurement these instruments are using, and whether these instruments are manually operated or they are self-operated or automatic instruments, what type of part these instruments are using. Okay, so these instruments, they are classified into different categories, and in this video we are going to study about the classification of measuring instruments. So let us start with it. We are having the first classification of measuring instruments is absolute and secondary instruments. So this type of classification of measuring instrument into absolute and secondary instrument, it is on the basis that what method they are using. Like in absolute instrument, the result of the measurement or the unknown quantity, it is measured in terms of the constants of the instrument. Okay, we are not directly reading the unknown quantity or directly reading the values of the unknown quantity. We are measuring it in terms of the constants of the instrument, whereas in secondary instrument we will directly measure the value of the unknown quantity. So just write the definition of these absolute and secondary instruments. So absolute instruments, they give the value of the measurand. Measurand is the unknown quantity which we want to measure in terms of the instrument constant and its deflection. Whereas the secondary instrument, they give the magnitude of the unknown quantity to be measured directly. Directly they will provide us the value. Now if we talk about the example of the absolute instruments, The tangent galvanometer, it is a type of absolute instrument because this tangent galvanometer, it provides the value of the unknown quantity in terms of its constants. Like it will indicate the value So here the tangent galvanometer, it is measuring the current, and this galvanometer, it is not directly giving us the value of the current. It will give its value in terms of the tangent of the angle of the deflection produced, the horizontal component of the earth's magnetic field, the radius, and the number of turns of the wire. So it is measuring the current, but it is providing the value indirectly. So this is a type of absolute instrument. Another example is the relays. Relays current balance. So this relays current balance, it indicates the value of the current in terms of the relays constant. So these are the example of absolute instruments where the value of the measurement, it is in terms of the instrument constant and its deflection. Example of secondary instruments are like we are measuring the current with the help of an ammeter. So ammeter, it will directly indicate the value of the current. It is giving directly the value of the current to us by the pointer deflection over the scale. So we can directly read the value of the current from the instrument. So it is a type of secondary instruments. Now the secondary instruments, they are also further classified into three categories. These three categories are indicating, integrating, and recording instruments. So secondary instruments, they are classified into indicating, integrating, and recording instruments. In the indicating instruments, we have a pointer, and this pointer is deflected over a calibrated scale. So the value of the measurement, it will be indicated by the pointer deflection. Okay. So in the indicating instruments, indicate the magnitude, so the indicating instruments, they indicate the magnitude of the unknown quantity when it is being measured. At the time of measurement, the value is directly indicated on the scale, and here it uses a pointer that moves over a calibrated scale. So these types of instruments are called the indicating instruments, like in the ammeter, in voltmeter, in the ohm meter, watt meter. All these instruments, they have a pointer, and this pointer is deflected over the scale. On the scale, we have the divisions. So these divisions, we can directly read the value from the scale. So at the time of measurement, like suppose we are connecting a conductor with the ammeter, we want to measure the current across the conductor. So we are directly getting the value of the current through the scale. Next, in the integrating instrument, we measure the value over a period, like over a period we are measuring the value of the unknown quantity, and those values they will be summed up and then we will take the average value. So integration is done over a period of time, or the area is calculated. That is why the instruments are called the integrating instrument. So integrating instruments, they measure the total amount of either the quantity of electricity provided over a period of time, or the amount of electrical energy supplied over a period of time. So over a period of time, like suppose for 1 hour or 2 hours, we are measuring that how much electricity is supplied to the instrument. So we are calculating the total amount here. We are integrating the total amount or the total area under the curve. When we are measuring integration we are doing, so those types of instruments are called the integrating instruments. Like the instruments which measure the power, like energy meters and the ampere hour meters, so they measure the amount of current which is supplied over 1 hour, or they measure the amount of electricity supplied over 1 hour. So these instruments are called the integrating instruments. The third classification or the third type is the recording instruments, in which we record the value of the unknown quantity over a paper. And then because this type of recording is done because we want to analyze the value of the unknown quantity, like if any variation is coming out in the value. So recording is done of the measurement, like we use a pen, and then this pen is connected with the measuring value. So this pen will move over a paper, and continuously we are recording the values of the unknown quantity. So the recording instruments, they keep a continuous record of the variations in the magnitude of the unknown quantity. Like for example, we have the recording instruments like the recording voltmeter we are having, or the instruments in which the paper is used on which a continuous record is taken. Okay, so the first classification is the absolute and the secondary instruments. Secondary instruments further classified into indicating, integrating and recording. Now next classification of measuring instruments is on the basis of the signal used by them, like analog and digital instruments. So if the output of the instrument, it is an analog signal in the analog form, so that will be an analog instrument. And if the output of the instrument, it is in digital form, so the instrument is called a digital instrument. So if the output of the instrument, it is in the analog form, so that will be called an analog instrument. An analog output means analog signal is a signal in which the values of the quantity, it is continuously varying with the time. So if the signal is provided in a continuous fashion, like if we draw a signal, this is the time and this is the amplitude of the signal. So if this type of signal will be called an analog signal. Here the value of the signal is varying at every instant of time. So if this type of output is provided by the instrument, that will be called analog instrument. Whereas digital instruments, they give a digital output. means the output will be in the form of discrete steps. If we draw a digital signal, this will be the amplitude. Again here we will have the time. So suppose at this instant its value is this, at this instant its value is this. So if in this way the signal is changing, that will be called a digital signal. That means in the form of discrete steps we are having. So this is it depends upon the type of output given by the instrument. If it's an analog output, that will be an analog instrument. If it is a digital output, then we have the digital instruments. Example of analog instruments are like analog ammeter, analog voltmeter, in which we are having the instrument. Here we will have the pointer, and this pointer is deflected over the scale. Okay, so these are the type of analog instruments. In digital instrument like digital multimeter, we get the direct reading over the LCD. Like suppose if we are measuring the current, so we will directly get the value 1 ampere on the LED on this screen of the digital multimeter. So these types of instruments are digital instruments. Next classification of instrument is based upon the process. Like if it involves a mechanical process, then they are called mechanical instrument, electrical instruments and electronic instruments. Now in the instrument we get the value of the unknown quantity with the help of a pointer. Now when this pointer it will be deflected due to some mechanical process, then instruments are called mechanical instruments. If the pointer is deflected due to some electrical process, those instruments will be called electrical instruments, and the instruments in which the pointer is deflected due to some electronic mechanism, then those instruments are called electronic instruments. Like for example, mechanical instruments like if we have the galvanometer. In the galvanometer, the pointer is deflected due to the movement of the coil. This coil is placed in the magnetic field of a magnet, and due to that magnetic field, when the magnetic field it changes from strong to weak, the pointer will be deflected and the coil is rotated. So due to the rotation of the coil, the pointer is deflected over a scale. So that is a type of mechanical instruments. So we can say that in mechanical instruments, the pointer is deflected due to some mechanical process. Now these mechanical instruments, they are somewhat heavy because mechanical parts are involved in them, and because these mechanical parts they are very heavy and friction is caused between these parts, so these instruments they are very slow in process. So the pointer is deflected very slowly, and the value or the readings we can take from the instrument, that deflection is very slow. So they are slow in their working. Now electrical signals, here due to some electrical process, if the pointer is deflected, then those instruments are called the electrical instruments. So when a pointer is deflected due to some electrical activity, like when we are measuring the current through the ammeter, so due to the current flowing through the ammeter, the pointer is deflected. Okay, so these types of instruments are called the electrical instruments. Ammeter, voltmeter, the ohm meter, all these are electrical instruments. In the electronic instruments, they are the semiconductor devices in which we have the electrons are involved. So due to the movement of electrons, the pointer is moved over a scale. Okay, due to movement electrons, the pointer is deflected. So here some semiconductor activity is involved, that is why these are known as electronic instruments. Example is like the CRO, that is the cathode ray oscilloscope. In the cathode ray oscilloscope we have the electrons. These electrons are excited and they are placed in between a cathode and anode, and due to which a magnetic field is present, and due to the magnetic field, due to the presence of the magnetic field, the electrons are deflected. So due to the movements of electrons, we have a pointer which moves on the cathode ray oscilloscope screen, and on that screen the pointer moves over the scale. So the movement of pointer is caused due to the movement of electrons, due to the presence of electrons. So electronic instruments example is CRO. For mechanical instruments, we were having the example of galvanometer. And electrical instruments, we are having the example of ammeter and voltmeters. So this is a type of classification of instruments based on the activity involved, which is causing the deflection of the pointer over the calibrated scale. The next classification of instruments is manual and automatic instruments. So as the name suggests, in manual instruments, those instruments which are manually operated, means we need an observer, and that observer is going to keep a record of the readings of the instrument. So here always an observer is required to measure the values, whereas automatic instruments, they do not need the presence of an observer. They will directly give us the value will be indicated by the instrument. Okay, so manual operated instruments. So manual instrument, if we talk about its example, the example is a resistance thermometer, incorporating a Wheatstone bridge. So in this mechanism, resistance thermometer, we are measuring the resistance by using the temperature. Okay, so resistance thermometer, we need an observer to keep a record of the temperature readings. That observer is going to make a table for the temperature measurement, and then the resistance will be measured. Okay, so manual instruments, So manual instruments, they always need the service of an operator, whereas automatic instruments, they do not require the service of an operator. Example of this is a glass tube thermometer. In the glass tube thermometer, no operator is required. The mercury will be deflected, and through the deflection or the level of the mercury, we can directly read the value of the temperature. So this is the classification based upon the presence of the operator, is whether it is required or not required. Next classification of instrument is based upon the power used by the instrument, whether the instruments, they are self-operated or they are power operated. So in self-operated instruments, no outside power is required for the operation of the instrument. For example, the dial type indicating instrument. In these instruments, we directly connect the instrument in the circuit, and the instrument, it will not require any type of power. It will directly indicate the value of the measurand. So here in self-operated instrument, no outside power is required for the operation of the instrument. Whereas in power operated instruments, some type of external power is required for the operation, like electricity is used, and also some compressed air or hydraulic air supply is also required. So here some external power is required for the operation of the instrument. That is why they are called power operated instrument. Example of such instruments are the electromechanical instruments. In the electromechanical instruments, electricity is provided, and due to that electricity, the magnetic field is generated, and due to that magnetic field, the pointer is deflected. So here some external power is provided so that the instrument can work. Okay, so that is why it is called power operated instrument. Some external power is required. Whereas dial type indicating instruments, in that you can see that when we connect those instrument in the circuit, no power is required. It can directly give us the value of the unknown quantity. Like when we are measuring voltage, what we do, we connect the voltage in parallel with the conductor, across the conductor, and it will give us the value of the voltage. Okay, so it is not using any type of power. That is why it is called self-operated instruments. Now next classification of instrument is based upon the type of method they are using for the measurement. Like if they are using the deflection method and the null method. In the deflection method, we will have a pointer in the instruments, and that pointer will indicate the value of the measuring quantity. Whereas in null methods, we have a null value. Okay, we are going to make a value nullified, so that like in the bridges we used, in the Wheatstone bridge, we are measuring the resistance by making the value across the galvanometer as 0. So when the galvanometer indicates null deflection, then we can measure we can say that the bridge is balanced, and we can measure the unknown resistance. So next classification is deflection and null output instruments. So the next type is the null output instruments. So in null output instruments, in these instruments, a 0 or the null indication, it will lead to the determination of the magnitude of the unknown quantity. Let's take example of these two types. The deflection instruments examples are the PMMC instruments, that is permanent magnet moving coil instruments. Okay, permanent magnet instruments. In these instruments, a coil is present in between a magnet, electricity is provided, and due to that electrical field, a magnetic field is generated due to the magnet, and the coil in between the magnet, it is magnetized. Okay, so due to the movement of the coil, the pointer which is connected to the coil, that is deflected over the calibrated scale. So the value of the unknown quantity, it is measured due to the mechanical movement, and that mechanical movement of the pointer is caused due to the activity of a or due to the movement of the coil. So example of deflection instrument is PMMC instrument, that is permanent magnet moving coil instruments. Okay, so here we will have a coil, and this coil is placed between the magnet, north and the south poles of the magnet, and to the coil a pointer is connected. Okay, so when this coil moves between this magnetic field, pointer is deflected over the scale. So we can read the value of the current by reading the values on the scale. So here deflection of the instrument indicates the measurement of the unknown quantity. Whereas in the null output instruments, like an example of the DC potentiometer, in that DC potentiometer, what we do, we have the slide wire potentiometer in which we move the key or knob over the slide wire, and when the galvanometer or it shows zero deflection, it means that the resistance or the EMF of the standard cell and the unknown EMF, they are equal to each other. So we are measuring the EMF by checking the null condition of the galvanometer. Also in the case of Wheatstone bridge, in the Wheatstone bridge also we measure the resistance, and this resistance is measured when the bridge is balanced, and balance condition occurs when the galvanometer it shows zero or a null deflection. So a zero or null indication, it leads to the determination of the magnitude of the unknown quantity. So example is the Wheatstone bridge and the DC slide wire potentiometer. Okay, so this was the classification of the instruments. If we draw a flowchart for the classification of instruments, it will be like measuring instruments, first classification we studied was absolute and secondary instruments. Secondary instruments, they were further classified into indicating, integrating, and recording. Next classification we studied was analog and digital. Next we studied the classification mechanical, electrical, and electronic. Next classification we studied was manual and automatic. Next we studied self-operated and power operated. And in the last we studied the classification deflection and null operated instruments. So this is how the measuring instruments they are classified. This is the flow chart for it. Okay, different classifications are there based on different criterias. Okay, so in this video we studied the classification of the measuring instruments. We studied the different categories of measuring instruments. So I hope that this topic is clear to you. Thank you.